Hey everybody, welcome to today's FME in Transportation Special Interest Group. Today is September 15th and John Ehlen is our presenter. And before we get started, I wanted to give everyone a few quick reminders. The first is we're always looking for suggestions for topics that would benefit you and the GIST community. And if you have any, please let us know now or through email or through the LinkedIn group or however. If you are interested in presenting, no matter how basic or complex the topic, please reach out to us because we're always looking for participants. And if you have any feedback or areas of improvement for this special interest group, please let us know. Okay, so today I will be giving a brief background to this group for any newcomers to the call. Then I will introduce John, our presenter. After the speaker introduction, we will jump directly into the presentation, followed by a live Q&A session. Finally, I will wrap up this meeting by talking briefly about next month's presentation. Okay, FME in Transportation is a special interest group with the purpose of curating and sharing success stories as well as best practices in applying safe software's feature manipulation engine, or FME, to the transportation sector. The creation of the SIG was coordinated with the assistance of Safe Software and is meant to be vendor neutral. The special interest group was created with the hopes of unifying local governments, state-level DOTs, and the private industry, as well as serving as a holistic framework in which knowledge will openly and actively be shared via monthly presentations from community members and industry experts. These presentations are intended to demonstrate and elaborate on real-world applications and success stories. Outside of the presentations, we hope this LinkedIn group will serve as a central repository for questions and answers as they relate to FME in the transportation sector. Our speaker is not Dave. Our speaker is John Ehlen. He is a project manager at Gistic Research. He has a master's of science in GIST, that's technology, not transportation, and sits as a voting member on GIS standards development groups through both National Emergency Number Association and the AGIC 911 Committee. Additionally, John serves as an adjunct professor at Embry-Riddle Aeronautical University, where he teaches GIS. His favorite FME transformer is a topology builder, and his least favorite food is pickles. That's good to know. Finally, as always, if anyone is interested in presenting or knows someone who might be, contact John, because John is the one who normally runs these things, at john.ehlen@gisticinc.com. All right, John, you ready to take it up?
I am, and I clearly forgot to update my own name on that slide, which is really, really funny there. So sorry about that, everyone. But we'll go ahead and get started here. So the first thing I want to do, you guys can see my screen now, correct?
Yes.
Okay, perfect. So the first thing I want to do is just show how easy it is to violate domains and why we've gone about this process. So here I've created an example geodatabase. There's nothing in here except for one domain for direction. This domain has north, east, southwest, northeast, northwest, southeast, southwest. I've applied that domain to this specific field here in this feature class. And so if we come over here and we go to editing, we can see that we can choose any of these domains and we can apply that domain, and we can stop editing and we can save it. So there we go. We've just put a valid value in here. But to violate this domain, it's really easy. Oh, wrong one. All we have to do is come in here and calculate this to anything outside of that domain, and we have just violated our domain constraints on our geodatabase. And this is a huge issue, especially with the rise of Python, with direct SQL queries, and especially with FME as well, because nothing prevents you from writing these domain violations directly to a table, even if there are domain constraints. Esri does provide a way to validate domains through the use of their data reviewer tool. but this costs extra money on an additional license, and it works only on one feature class at a time, which means you have to set this up to run consecutively across every feature class and look at these reports in that fashion, which is really not ideal if we can do this all in one swoop here. So now I'm going to show you guys kind of our end goal here and what we've produced with this before I jump into FME. And so the end goal of this process is to generate a report for management so they can come in here in a dashboard and see in near real time who is putting in these errors, whether that be a subcontractor, their own agency. And so the end goal is really this dashboard. And we have this pivot table here that can go, all the way to a summary form. So we just show you what feature class and what field contain errors and how many errors are contained in each of that field. And it is a little slow whenever I have all of this information running and streaming, especially over a remote desktop. But typically it's pretty speedy. So here you can see we have feature class, and then on a field by field basis, how many domain violations we have. But if we actually expand this table and go all the way into this, it has not only the incorrect value that's in that field, an account of those values, but it also has the editor who put the value in there. And it also has the actual object ID linking back to the individual records. So you can actually go back to this individual record in this feature class and see this value here and correct it all like that. Additionally, you can also export this table out and do a CSV or a spreadsheet, allowing you to join this back to the original data set and do edits in bulk based off of these values here. Aside from that, it also has the ability to filter based off of subcontractor agency. So we can see all of the errors that are put in by a specific subcontractor. Or we can look and drill down to see, individual editors or feature classes of interest here. And so this was the end goal, and this is only half of the end goal because this is just relating to domain violations. And the next step of this process is going to be incorporating LRS event violations. So out of bound events tied to non-existent routes, overlapping, things like that. So this is really our end product here. And now that we've shown that, this is what it's built off of. And I think it's kind of best for this to work backwards because it's confusing why we're doing this until you see what the output is. But essentially everything that we're writing to is this Google Sheet through FME. And so we have a tab for the summary so we can keep track of what date the summary was ran, the total count of records that were edited, the total count of error records we found, and then this QSequid, which will relate back to the individual records on the detail table. We also have specific parameters built into this process because we identified fields that we just don't care about. Data source data set, and temp review status. These fields will never have any data put into them that is like wholly relevant or controlled by domains, because there could be 1,000 used data sources every year. So the ADOT team identified for us to ignore this. And so you'll see in a bit that the user parameter allows you to specify any number of fields separated by commas, and then it will ignore those in the analysis. And then we have additional parameters for what the date dimension is, being month, how far back we were looking, and then the triggered update offset we'll talk about in a bit. And then we have the detail table, which is the individual record for each domain violation down to its object ID value and who did it and on what day they did it. So now that we've seen the end result here, let's kind of jump into the process and take a look at this. So this is the overall process, and I have made a very, very dumbed down workspace so we can kind of investigate this step by step, and then I'll show you where this is used in our main workspace. So the domain validation is actually fairly simple. And while we move through this, I just want to point out that we don't have a huge group of people in this presentation. So if you guys have questions, please just unmute yourself and blurt it out. Feel free to interrupt me and I'll answer them right there on the spot. There's no need for you to wait and forget the question until the end of this presentation. So this will require some knowledge of SQL, as well as some knowledge of how lists operate in FME to fully understand the process. I'm going to try and walk you through it as best as I can. but I'm not going to dive into exactly what's happening in all of our SQL code here. But essentially, what we're doing here is we are reading every table name that exists in the domain feature class, and we're reading every table name that exists in the database and doing a join on them. And so we are retrieving every feature class and field from the domain table, and then joining those to every feature class and field to get all of our feature class and fields that are domain controlled, allowing us to dynamically build SQL statements. And this is the same query that actually pulls domains out. And so if you'll notice here, we're selecting quite a few fields, but I'm only displaying 2 of those fields here. So we're only actually pulling feature class and field out of this query. But the reason that we're using the same query is because this query is used in other places, and just for consistency, it's easier to use the same exact query and limit what we show from it than it is to actually just create a new query in itself and have them in different places. And so if you see the select statement, we are actually just selecting feature class and field, and that's the result here, but we could add things like code or coded value or domain range. But what the Sql Executor does is it runs the SQL statement against the database and generates FME objects based on the results of that SQL statement. So I'm going to run this, and since it's SQL based, it's pretty fast, but I am working over a remote connection, so it's not as fast as it could be. Now, what we get out of this is duplicated records, because if we inspect each of these records, you'll notice that these are all access control feature class and access control field. So they kind of look duplicated, but if you look at the actual attributes in the feature information window, you'll see that they have different values here. So they have a value of partial control. This one has a value of full control. So these are the actual domain values associated with each of these records. And these will be used later in the process, but for now, we're only interested in getting every feature class and field that's controlled by the domain. So we run this output through a duplicate filter, identifying unique records on a feature class and field basis. So if we look at this, our key attributes are just feature class field. So we want a distinct pair of feature class and fields here. When we run this, we pare our data set down from 5,500 records to a little over 400. And what this is every feature class and field combination that is controlled by a domain in the database. And what we're going to use this for is to build a list of every field on a feature class basis to submit to a Sql Executor to generate and retrieve those data sets from the database. So once we've output this and we have our unique combination of feature class field, we run this through a list builder, and we group this based on the feature class. And so we get a list of every field that's associated with each feature class. And if you aren't too familiar with lists and don't use them a lot, this might look worthless and kind of confusing as what we've got here, because we only have a feature class. We now have no field information. But if we select any of these records and we come over here and we turn on the feature information window, we can see that it has a list attribute, and this list attribute contains every single field that is related to this feature class inside of this data set. Now, to get these back as an attribute, we want to concatenate this list, every object in this list together, separated by commas, and add it as a new attribute. And so what we end up with is this attribute here called field list. And this is every field that's controlled by the domain inside of the feature class it's related to, being its other attribute feature class. So what this allows us to do is dynamically build SQL statements to query every single field and every single feature class as they're updated. So tomorrow, if you added 5 domains and 5 new feature classes, when this process ran, it would find all of those feature classes that were added and all of the new fields that were added to the domain table, because it's pulling this information straight from the domain table.
John, real quick, what's being concatenated there, that's the code value as opposed to the, I guess you'd say, alias.
Absolutely, yes.
Okay.
It's the, yeah, and so let me see here. I have the domains. We can look at that really quick if you'd like. So this is the actual, this is the same query that we initialized over here, and it's creating the same object, but in this case, we're exposing all of the values here. So not just feature class and field, but also the domain name, the domain code, and that value for that domain.
Okay.
So you're correct, Adam. We are taking that code because the code is what you see in the table, and we'll be doing our joins off of and looking for fallouts on.
Okay.
Yeah, if that makes sense.
Okay, and just out of curiosity, does it tend to handle, I guess you'd say like text domains better than say like short integer domains, like where the coded value is like a 1, a 0, whatever?
No, so this is a very much dumbed down process, but our true SQL query actually pulls out domain type and gives us a range. So we can actually look at coded value domains and range domains.
Okay.
In the range domain case, our SQL query takes the minimum maximum range, puts them in one attribute separated by a comma, and then we split those out into 2 attributes and use that to validate whether the domain is with the values within the domain range. So it does work on both anything that's text-based that we can do a one-to-one join off of, and it does work on value ranges if we have that as well.
Okay.
Yeah, and I'll show you the value ranges in the other process. I didn't put that SQL query into this process, but we could, in theory, just grab it really quick and look at it. Let's see. Let's take that. I'm just going to do this. Sometimes I forget I can copy things directly between FME workspaces, so let me just do that. All right, so here we go. You know, we have a domain value type, and then we have a value and a value range. And so anything that has a value range, and if FME didn't sort things in that direction, we'll see that this is a range domain versus coded value, and then we get the value range it's associated with, and then we can make sure that the value of the field fits within that range.
Got it. Cool.
Okay. So moving on, we just concatenated our fields together. So we have a feature class and a field list. And if you're familiar with SQL, this should look instantly familiar to you because it's going to be a select field list from feature class statement. A very, very simple query here. And we're going to build that right now with the string concatenator. So these records get passed directly to our string concatenator. For this demonstration, I put a select top 50 in here, just so we don't have a billion records going through. One of the unfortunate things about this process is that since only the domain, like what I'm showing you here works on a SQL query basis. So when we run the SQL query, it's running against the base table in your database. The downside to that is you have to have all of your edits compressed to your default version and all of your state IDs removed from your database to have all of your edits in your base table. So this is not the preferred method to do it, especially if you have a lag cycle between your database compressions. You would want to use a feature reader like I do in my other process instead of a Sql Executor. But whenever you use a Sql Executor, it's a lot faster than the feature reader reading through an SDE connection. So this is why I'm just demonstrating it with this. But essentially, we're using our attribute values we've concatenated and a couple of constants here to build a Sql Select statement. So we're going to select the top 50 values from our field list. And then we're going to select our feature class name as our feature class, just so we have that tied to each record so we know what the feature class these fields came from. And then very simply, we're going to select those records from the feature class itself. So selecting all of these field lists down here from this feature class, and we're concatenating that statement in that fashion. So each of these records now gets, and I can see I forgot a space in here. Add that back in and rerun this. All right, so now we can see each of these has select the top 50 records from each of these fields that are domain controlled, and then select them from this feature class here. Now what we do is we actually build a list of those features. So this allows us to execute everything in one query here. and it's kind of funky. So what we get out of this is no schema. But if we look at the list this contains, it contains a list of every single SQL statement we just built. And similar to our last list concatenator, where we created a new attribute from this list, we're going to do that again, except this new attribute is going to be called execution statement, and it's going to contain all of these SQL select statements wrapped up together. So here we can see that we have one attribute that just contains 100 and something SQL statements to select records from the database. And all we do is we pass that execution statement to the SQL Executor, and we expose the feature class attribute that we're selecting. That way we know what feature class all of these records came from. This generally goes by fairly quickly. What takes the longest in this process is the next step, especially whenever we talk about doing anything relating to large data sets, especially with caching enabled. When we have caching enabled, it gets really, really hairy here. So we've selected all of these records here. And you can see that this record came from LRC Junction, and it's got a value in the fields down here. This isn't the important step here, but just bear in mind, all of these are records from different tables that we've selected all at once with that huge statement here. This is really the key to this process, is getting a unique record, or essentially pivoting your table so that you have your attribute name and your attribute value together. And we do this through an attribute exploder. So we are exploding our features, and we are listing our attribute name or our field name as attribute name, and our attribute value or the value of that field as the attribute value, discarding the geometry. But this is the pivotal thing here, is keeping the attributes. And so what happens is we end up with a unique record where we have a feature class, the field it came from, and an attribute value. But underneath the hood, since we chose to keep all attributes, this individual record also maintains all of the original attributes it had in here, including if it had last edit date or it had any of these other things, it would have those in there. But since those aren't domain controlled fields, I didn't read those fields, which is another detriment to the SQL Executor versus a feature reader. The feature reader takes a lot longer, but it reads in every single field rather than just these domain fields. So if your goal is just to do a report based on all of the domain violations, the SQL Executor is much, much faster and can do your entire database. I ran it across like 11, or I think it was maybe 19 million records. It took like 4 hours or something. But those 19 million records get exploded out from 19 million to a billion records or something. I had actually issues with the storage on my hard drive when I was trying to run this with feature caching. So I had to set a temp directory to store these files in on a network attached storage system, because it was crashing my computer by running out of memory, and FME would crash. So once we've exploded the attributes, you can see that we get a feature class and an attribute value here. So all of these attribute values are going to be what Adam identified as the code in the domain table. They'll be relating to the code of the domain table. Now, because not every record has a value, we don't want to process all of these null records through joins. And so the very first thing we do is we just test to see if that attribute has a value. And if it doesn't have a value, we just discard it, because there's no point in checking a domain violation if there's no value. That would be handled by a separate process, checking to see whether or not that table allows null values or not. But in theory, if it doesn't allow null values, they shouldn't be there. And if it does, then a null value should be fine. But what we end up with is all of these records here. So we have a feature class, a field name, and a value contained in that field. And this is what we're going to use to check the domains, essentially. So the next thing we do, just some cleanup. My feature classes are coming in here with the DBO, the table prefix in there, and I didn't read the domains that direction with my SQL query. So instead of changing the SQL query, I just use a string replacer and I strip out DBO from any table names there. And then I do the same thing. I just make all of the attributes uppercase. Well, the attribute name and the feature class. So we get a feature class and a field name. That's all in uppercase. This eliminates any weird inconsistencies in FME. SQL does not care about table name case generally. I think you can set it up that it might, but I think in general, if you put route ID with no caps or route ID in all caps in a select statement, it's going to select route ID. However, FME is a character and case by case on a character by character level engine. And so if we try and join two fields together that are lowercase and uppercase, they will not join together. So that's why we make everything uppercase here. The next thing we do is we just rename attributes. That way it's easier to keep track of. So we rename the attribute name to field and the attribute value to value. This just eliminates any confusion for myself farther in the process. Something you'll also note is that I've color coded these lines here. And so the pink lines represent all of our records coming in, and the blue lines represent the domains coming in. And this is something I like to do just because it helps me keep track of the individual streams. So before we get to our filter incoming records, let's go look at the domains and see what we're doing. I think I already showed kind of what we were doing a little bit. This is the same exact domain query we looked at, except in this case, again, we're exposing all of these fields here rather than just feature class and field. And we're not taking a limited sample of these. We're using and processing all of them in bulk. So the very first thing, again, we uppercase feature class. That way we can join this correctly. And then we'll do the same thing. We'll replace DBO here. And quite honestly, I thought this was not necessary. I thought these were being read in without DBO already. So I think I could actually eliminate both of these string replacers here, and this process would be the exact same thing. And it's possible I put this in here just because in our final report, we don't display who owns the table or what schema the table's in, because the editors don't do any database stuff. They're not familiar with schemas. They just know table names. And so I think that might be the reason I did that, but that's something I've just confused myself with. String case changer. And again, we're going to uppercase things here. This looks like a redundant of this one here. So I threw this together yesterday. We can actually delete the string case changer too, and we should have the exact desired result of the uppercase things. Now, the next crucial step here is if we went straight to joining this domain violation or the table events with the domains, we would have a ton of fallouts, because if we look at this, we have a bunch of feature classes and a bunch of fields in here that are not domain controlled. So if we were to join our feature class events to our domains on field, value, and feature class, we would have all of these things falling out: FME feature type, FME geometry, FME type, feature class. All of these things would fall out. So the very first thing we need to do is identify which of these attributes we have that we've exploded are actually controlled by a domain. And we do this here by filtering incoming records. Hey, Eric, nice of you to join us.
I'm sorry, I'm the worst. I don't know what happened and why it's not on my calendar. Sorry, keep going. Sorry.
Yeah, no worries. And so to do this from our domain stream, again, our domain stream contains a feature class, a field, a value, the domain name, and then the code related to that value. So the very first thing we do is we just keep the feature class and fields coming out of this. This is very similar to what we read originally at the beginning of this process. However, we're going to do it again to kind of get rid of these exploded attributes. So now that we've got our feature class field, exactly like what we did before, we're going to take our duplicate filter. We're going to get a unique record for each feature class and each field, and it should match what we had before at the left. 400. That's interesting that it doesn't. We have 467 here and 433 here. So there is some discrepancy that I off the top of my head could not tell you why those numbers are different without looking into this further. But for demonstration's sake, we're just going to keep moving on here. But before someone else calls me out that those numbers are different, I'll point that out myself. So the next thing we're going to do is we're going to join this together. And since these attributes should have the same name, we're just going to take our right stream, and this is what's going to be used here. And so we're going to join this on feature class and field. And essentially, because we're doing this join, anything that joins coming out of this is a record that is controlled by the domain, and anything that doesn't join this is a field that is not controlled by the domain. And these are going to be typically the FME feature attributes that are under the hood that whenever we explode get exposed. And so if we look at the unjoined left, and again, left would be coming from our domain stream, we can see that in this limited subset of records that I've taken, and again, we're using that top 50 record query, so we're not reading every record here. You can see these are all of the feature classes and fields that are not contained in the incoming event stream. And then if we look at the unjoined right, right being the events coming from our database table, we can see that these are all of the fields that are obviously not tied to our domain stream that we don't want to check for domain violations in. And all of these are going to be the FME feature types, FME geometry, that sort of stuff, but they're attached to every single attribute. And so it's crucial to filter these out. Otherwise, in our next join, you're going to have all of these unjoined as essentially a domain violation when they truly aren't. So what we have coming out of the stream is a feature class and a field with its value, and these feature classes and fields exist in the domain table and are controlled via the domains. And the very next thing we do is we join our domains to our features based on the feature class, the field, and the value. And again, in the domain, as Adam pointed out, that's called code, because these are coded value domains. But on our right stream being our features, this is value. So this can be a little confusing, but we're going to do an inner join. We're going to take our attributes from the left. This could be from the right. It shouldn't matter because we're only interested in what joins here. And once we get this, coming out of this joining process, we will have records that are valid are going to be joined. And so we can see here the value and the code totally matched. Everything coming out of the join port is a valid record and abides by the domain constraints. But if we look at what's coming from the unjoined right, we have all of these values here that do not exist in the domain table. And if we look at LRSC channelization and paint in the original domain table, we'll see that it does not contain a value of P here. So let's investigate that really quick. Interesting. Guess it doesn't feel like searching today. Guess we can brute force it. Okay, I spelled that wrong. Paint all caps, that's why. And DBO. That is why I removed DBO, because it is very annoying to find. It dealing with the schema when I'm trying to go back and find these records always throws me off. And cache values, I guess it's not uppercase here yet. There we go. Okay, so here we can see all of the codes that are valid inside of this domain for this feature class in this field. And as you can see, it does not include the value of P, which is what the process identified. And so we have all of these fallouts here. Again, these are values that exist in the table that violate the domain, and it's a record by record basis. And so if we look at this, if we had read in object ID, object ID would be one of the attributes that's stored here as well. And then from that, we can do some really interesting things, just using a series of statistic calculators. And then we can generate detailed and summary reports. Now, I think it's not crucial, but we could have put all of the unjoined records directly into an Excel spreadsheet and use Excel to generate summary tables and pivot tables and stuff. But if we use a series of statistic calculators, we can see we get the same desired result. So the very first thing here we have is our complete record set. This is every record, a one-to-one basis pretty much, with a count of it there. And then the next thing we're going to get is a summary based off of the count of them on feature class, field, and value. So if we look at this, we can see we have this many values, this many times on this field in this feature class. And if we do another statistic calculator on this, we can get the count of invalid values by feature class field. And so here we drop the value and we just show how many counts exist in each field per feature class. And then we do the same thing, but this is just a count per feature class. And so it's kind of this multi-tier layer where you can see each individual value, how many times it occurred in what feature class and what field, or you can see how many counts of errors exist in the field in the feature class, or how many errors exist in the feature class overall entirely. And then from there, I just threw in a generic feature writer here, writing to an Excel spreadsheet, and we can look and take a quick peek here once this generates it, what we've created. And again, this is a very dumbed down process in terms of what we're using in production, but I think it gives you a kind of an idea of the power of this. So if we sort this and we look at this, we have a count by feature class. Now we have a count by feature class field. We've got a count by feature class field value, and then we've got the detailed version of this, which I actually routed the wrong stream, but this should have been a one-to-one of each value per record, essentially. So that is, again, the dumbed down process, which is, this is the entirety of it, excluding this here. If we remove this, just this stuff here is really the meat of the domain validation process. And once you understand how it works, you can then apply this to bigger sets and use this as its own custom transformer, which is what I've done. So here, this is the entirety of that process with a couple of enhancements. Because we're doing so much data and filtering so much data through this, the very first thing that I actually do here is scroll the wrong way. I take my incoming record stream and I sample it just to get the first row, just to get the fields that are incoming for my data stream. The next thing I do from that is I keep some attributes, being the feature class field. And in our original process, we use the domains, the process I just showed you, we use the domains to filter the incoming data sets to only look at records that exist in the domain tables. Previous to doing that, in the production process, we do the reverse. And so we use a list of all of the incoming fields and feature classes to filter the domains, because when we're looking at a day-by-day basis, our incoming feature classes might not have, they might not be all 112 feature class in the database. It might only be 5 or 10 of them. So the very first thing we do before we do any joins is we get rid of all of the superfluous domains that we're not going to be using in this process. And then coming out of that, we do the exact same thing that I showed you. We get the duplicate domain fields, and then we filter our incoming attributes based on whether or not they meet the domain standard or not. So whether or not they are controlled by the domain. And again, these are your FME geometry, your FME feature types, all of this stuff will be created when you explode the attributes, and you will need to filter that out. And so, but if you have a million records coming through this, this process can take a long time, because whenever it gets exploded, if you have 50 fields and one record, when you explode that and pivot it, you now have one field, but 50 records. And so if you have 100,000 records coming in and each record has 50 fields, and you pivot that table, you have 50 times 100,000. You have a lot of records moving through this process, which can slow down your joins significantly. So it's crucial in production that you filter both. You filter the domains coming in first, and then you filter the fields coming in against those domains. Otherwise, you could be joining 5,000 records against a million records instead of 100 records against a million records, and for no reason. So same thing here. This process is a bit more complex, and Adam, you'll notice here I'm filtering data based on a range domain or a coded domain. And so our coded domain does exactly what I showed you. It just does a straight feature join across the domains and the coded values. And this tells us whether or not we have a fallout, and then it gets kicked out to our output. And in terms of the range domain process, we do essentially the same thing. We join the records together, and this allows us to pick up the coded range for each record or for each field. And what we do with that is we create a new attribute that is the value range. And again, we looked at that previously. That is our low range and our high range separated by a comma. And so we will have a new attribute that would say, 0, 50, and that would be our range for valid records. And that record or that attribute would be appended and joined to our incoming event records. And so we have our event value and we have the range that it fits in next to each other. And simply, we just use the attribute validator saying, does our attribute validator fit in the range of the value range from its domain? And if it does, we just leave it, we don't care about it. And if it fails that check, then we pass it through this process to the output. And I don't think I'm going to dive into our entire process because it's pretty complex. Everything we just saw happens inside of this single transformer here. So this RH domain checker version 2 is this entire process. And what we get out of that, we do a lot of processing too. So again, that domain checker is just this box in our process. But our process does a lot of other things. And the other superfluous things are what allow us to build the dashboard. So we have steps in here to, I have it disabled right now, but for a rolling dashboard, which was the initial idea, we would delete records in the table that were older than 4 weeks old. So it's just like a kind of monthly roll up that runs day by day and drops records that are 30 days older. And we do this through date time calculations, testing, and then using a feature writer to update or delete things out of that Google Sheet. And then we have other steps in here. So I mentioned that in the other process we looked at, we were using a Sql Executor. And that's really nice because you can define exactly what fields you want to read in. So you don't read in 50 other fields that are not necessary. And this kind of, that's the reason we have to do those joins in the other workspaces, because we have a ton of fields that are not domain controlled. But the downside, as I mentioned, is that you're not reading the current version. You're reading the base table, which doesn't include all of the add and delete table edits. And so if you want to query in real time what's in your database at this very moment, you really have to use a feature reader over an SDE connection and let Esri handle the manipulation of the add and delete tables and aggregating those back into its default version and presenting you with, at this current point in time, what is a valid record. So the other process we had, we read all of the SQL tables at once. In this process, we've experimented with something different, where we're selecting all of our table names that start with our LRS, E, I, or N, and excluding some extra caveat things here, and ensuring that these items we're reading in have a last editor date and a last editor field. And in this case, we're also looking for from and to measure. So these are going to be our linear events. And then here it's the exact same query, but instead of from measure and to measure, we are just ensuring that they have a measure column. And this would be our point events. And then finally, we read in our route events. And you can see that I kind of color coded these and I'm passing them through different streams here just so we can keep track of them. But some of the key things that allow us to build a dashboard are really that we're using this feature reader and that it has every single field attached to it. So at the very end of this process, once we've identified the domain violations, we can then expose who made that edit, when that edit was made, what its object ID is, and then pass that information to the dashboard, which relates it back to its original table. The only other things that I would like to mention, I think, are, if you're familiar with LRS systems and the concept of edits propagating through the system or through the events based on a route change, we identified the need to signify whether an edit was associated to a user based off of an automatic triggered update or a update that they performed manually. And the way we do that is by looking at date, time, and then joining those. Let's see, I see someone put something in chat. Gotcha. Yeah, thanks, Daniel. So, the key here is that if you edit a route at milepost 3 and you change the measure or the dimensions of it, the roads and highway system is going to propagate that edit through all of the affected events along that route. And so it's entirely possible that you can have items assigned to a user, a domain violation assigned to a user out of this process that actually, the violation could have occurred in 2013, but no one caught it. And so a user edits a route, that route triggers an automatic update of the event. And because the user edited the route, his username is propagated and attached to the event. And so to mitigate this, we have a process in place to say, did this event occur on the same feature class in the same field on the same day by the same user? And if that's the case, then we check a time frame. Okay, did this event edit happen within 2 hours of our route edit? So giving some editors grace period of making an edit, saving and posting that edit. And we've actually built that as a parameter here. So if we look at this workspace, we can specify what fields we want to ignore. So if we no longer cared about looking at a field called direction, right? We can specify direction here, and this will be dropped from our analysis and never reported on until we change that. We can also specify whether we want to query the database back a year, a month, a week, a day, or an hour, and we can specify how many units of that. So here we're looking at 24 months. This could also be 50 days, or this could be 100 hours, or 1,000, 10,000, 50 hours, whatever you want. And then this time offset in hours is our time delay to catch automatic triggered updates versus manual updates. So if we specify a value of 6 in here, this would say, if I found a record in the database that was edited on the same, or an event record that was edited on the same day by the same user in the same feature class, tied by route ID to my route network that was edited, then I would say that this is an automatic update, not something that they manually did. The ADOT team identified us as having a 2-hour window that they could post their edits in. So anything that happens within 2 hours, we flag it as being a probable automatic update, but it's still worthy of consideration, because even if the edit is not an automatic update, then or even if it is an automatic update, it's still a domain violation and should be taken care of. But we want to be able to say that, like, they didn't manually put this in. This is just an old thing that needs to be taken care of. So this process here identifies the route and event edit concurrency, and then builds a flag that that we use to say whether or not that is a automatic update. And then we also have a process to join back identify who the editor was. And so we're using our same Google Sheet here. And essentially we're just reading our incoming table from Google Sheets and then joining our usernames and their workplace agency back to their individual records for display in the dashboard. And so with that in mind, if we come back in here, this is what I'm talking about, that join. So we have our user ID, our first name, last name I've blacked out for their privacy, their organization they work for, and whether they're a current or former employee. And we're using this table dynamically every time we read this to join the user IDs from the database with their name and place of employment. And then that gets displayed in the dashboard here. So here we can go back, and that's what allows us to filter by agency, or to filter by editor, or to filter by specific edit dates. So if you wanted to see all of the edits that took place on July 30th, you could come in here and you could see that on July 30th, once this loads, there was one layer that was edited, 2 fields that were affected, 1 editor did this from 1 agency, and these were the values and the count of the values on that specific day in this feature class on this field for this editor here. And with that, I think that's all I have for this presentation. So if anyone has any questions or comments, feel free to unmute and hop in here. thanks for the feedback, you guys. I hope you guys found it valuable. And if anyone wants to take the sample workspace I made, if you're using a SQL database, it can certainly run against your database. It's pretty genericized. If you're using an Oracle database, you'll have to get in contact with Esri or read some documentation on how to build the SQL queries to read the XML documents in the Oracle database. It is very cryptic. And I'm going to give a big shout out to Bo Guo, my employer, for helping me with those SQL queries, because my knowledge of using SQL to read cryptic XML tables is lackluster at best, I would say. And so this process would be a lot more difficult had he not stepped in and helped with some of those SQL queries there. Yeah, but if anyone wants that sample workspace, I can certainly pass that your way. You'll just have to change the parameters for what database you're reading from and all that kind of stuff, but you can play around with it. Yeah, it really should. And that's why I titled this presentation in that way, is you know, where Esri left off, because they left this glaring hole in their data. And like, if you think about a domain constraint, you would imagine that you would not be able to violate it with their own field calculator tool, right? If you put a domain constraint in your table and then you use their built-in tool to manipulate your table, the assumption being you would not be able to violate the domain constraints with built-in tools. But that, as we've demonstrated, is not the case. These are very, very easy things to get around. And I think that they've sort of cleaned this up and they're working towards it, bettering it in terms of attribute rules in ArcGIS Pro that you can use. And so these would actually prevent you from putting an edit into a database based on an invalid attribute rule. So attribute rules kind of are replacing domains in that fashion. But for all of the people who can't move to ArcGIS Pro yet, who are still tied to the roads and highways that's functional in ArcMap, unless you use data reviewer step by step on one feature class at a time, you have no way to do a domain violation, you know, query against your database all at once. And with that, I think we can wrap up here. I don't have anything else for anyone, so if no one has any questions, I'll just thank you all for attending. It was very nice to be able to share some of the cool things I've been working on lately, and I hope you guys learned from it. And certainly just reach out to me if you guys want that workspace or have any questions or want to discuss domains or FME. Thanks, everyone.
Thank you, everyone. Thank you, John. That was fantastic. Everybody's quiet today.
Yeah, again, sorry for being late. I don't know what happened, but I just want to reiterate, we tentatively had a presenter. I don't know if you caught this at the beginning, but we tentatively had a presenter for October, but we're looking for somebody to present. So if you have anything, no matter how trivial or complex, right, we want to see it.
Absolutely, yeah, I think that's a great point. You know, a lot of the things that the people who run this SIG are so ingrained in FME that we have a lot of high level workflows that we do, and they can be really cryptic for people who are just beginning to use FME in their processes. And so I think it's incredibly valuable to have even simple workspaces showing off things that you're doing, because there are people out there who don't understand FME and what it can do in its entirety. And even very simple things like just data translations from one file format to another using FME or schema mapping things are really cool and really powerful, but they're hard to wrap your head around until someone shows you.
Well, if you have something to show, get a hold of somebody on the SIG, and you only have to be 10 minutes on your presentation. You don't have to do a whole hour or even half hour. So.
All right, I'm stopping the recording now.